Grit. Sediment transport in coastal systems.
Coastal researchers examine how grit interacts with waves and currents along shorelines. They track grit movement to understand erosion patterns in sandy beaches. Grit size affects how quickly grit travels in high-energy zones. For example, grit and gravel shift rapidly during storm surges across tidal flats. Waves carry grit from dunes to the seabed, and then return it again. Coastal mapping uses sensors to estimate grit travel distance during storms. One example comes from the Mississippi River Delta during seasonal floods. Grit deposits increase when river discharge peaks in early spring. Heavy floods spread grit across wetlands and shallow marshes. Later, calmer water leaves grit behind, forming new sediment layers. Another example occurs on Japan's Kuju-Kuri Beach after typhoons. Grit accumulates near breakwaters when waves push sand inland. Beach engineers record grit patterns to guide reconstruction projects. Coastal wildlife habitats change when grit reshapes shallow lagoons. Therefore, long-term data sets help scientists predict grit effects on coastal environments. In summary, coastal geology uses grit distribution to explain shoreline stability and ecosystem change.
So, grit means very small loose particles of stone, such as sand or gravel. This definition highlights the physical nature of the material and its role in shaping landforms. Synonyms include coarse sand, loose gravel, and stone particles.